elementary course in synthetic projective geometry by Derrick Norman Lehmer. Preface. The following course is intended to give, in as simple a way as possible, the essentials of synthetic projective geometry. While, in the main, the theory is developed along the well-beaten track laid out by the great masters of the subject, it is believed that there has been a slight smoothing of the road in some places. Especially will this be observed in the chapter on involution. The author has never felt satisfied with the usual treatment of that subject by means of circles and anharmonic ratios. A purely projective notion ought not to be based on metrical foundations. Metrical developments should be made there, as elsewhere in the theory, by the introduction of infinitely distant elements. The author has departed from the century-old custom of writing in parallel columns, each theorem and its dual. He has not found that it conduces to sharpness of vision to try to focus his eye on two things at once. Those who prefer the usual method of procedure can, of course, develop the two sets of theorems side by side. The author has not found this the better plan in actual teaching. As regards nomenclature, the author has followed the lead of earlier writers in English and has called the system of lines in a plane, which all pass through a point, a pencil of rays, instead of a bundle of rays, as later writers seem inclined to do. For a point considered as made up of all the lines and planes through it, he has ventured to use the term point system as being the natural dualization of the usual term plane system. He has also rejected the term foci of an involution, and has not used the customary terms for classifying involutions: hyperbolic involution, elliptic involution, and parabolic involution. He has found that all these terms are very confusing to the student, who inevitably tries to connect them in some way with the conic sections. Enough examples have been provided to give the student a clear grasp of the theory. Many are of sufficient generality to serve as a basis for individual investigation on the part of the student. Thus, the third example at the end of the first chapter will be found to be very fruitful in interesting results. A correspondence is there indicated between lines in space and circles through a fixed point in space. If the student will trace a few of the consequences of that correspondence and determine what configurations of circles correspond to intersecting lines, to lines in a plane, to lines of a plane pencil, to lines cutting three skew lines, etc., he will have acquired no little practice in picturing to himself figures in space. The writer has not followed the usual practice of inserting historical notes at the foot of the page, and has tried instead, in the last chapter, to give a consecutive account of the history of pure geometry, or at least of as much of it as the student will be able to appreciate who has mastered the course as given in the preceding chapters. One is not apt to get a very wide view of the history of a subject by reading 100 biographical footnotes arranged in no sort of sequence. The writer, moreover, feels that the proper time to learn the history of a subject is after the student has some general ideas of the subject itself. The course is not intended to furnish an illustration of how a subject may be developed from the smallest possible number of fundamental assumptions. The author is aware of the importance of work of this sort, but he does not believe it is possible at the present time to write a book along such lines which shall be of much use for elementary students. For the purposes of this course, the student should have a thorough grounding in ordinary elementary geometry, so far as to include the study of the circle and of similar triangles. No solid geometry is needed beyond the little used in the proof of Desargues' theorem, 25, and except in certain metrical developments of the general theory, there will be no call for a knowledge of trigonometry or analytical geometry. Naturally, the student who is equipped with these subjects, as well as with the calculus, will be a little more mature and may be expected to follow the course all the more easily. The author has had no difficulty, however, in presenting it to students in the freshman class at the University of California. The subject of synthetic projective geometry is, in the opinion of the writer, destined shortly to force its way down into the secondary schools, and if this little book helps to accelerate the movement, he will feel amply repaid for the task of working the materials into a form available for such schools as well as for the lower classes in the university. The material for the course has been drawn from many sources. The author is chiefly indebted to the classical works of Rey, Cremona, Steiner, Pontellet, and von Staudt. Acknowledgments and thanks are also due to Professor Walter C. Eels of the U.S. Naval Academy at Annapolis for his searching examination and keen criticism of the manuscript. Also to Professor Herbert Ellsworth Slot of the University of Chicago for his many valuable suggestions, and to Professor B. M. Woods and Dr. H. N. Wright of the University of California, who have tried out the methods of presentation in their own classes. D. N. Lehmer, Berkeley, California. An elementary course in synthetic projective geometry. This book was written by Derrick Norman Lehmer, Assistant Professor of Mathematics, University of California. It was published by Ginn and Company, Boston, 1917, and is now in the public domain. The text is available for free download at Project Gutenberg, read by Jim Renholt. Programming and illustrations by Jim Renholt, 2020. Corrections and comments are appreciated. Thank you for listening.